Find the value or values of c that satisfy Rolle's theorem for the function f of x is equal to 4 divided by the quantity x squared plus 1 on the interval from -3 to +3. All right, so the first question is our function continuous? Well, with rational functions, does the denominator ever equal 0? And the answer to this is no, especially within this given interval. Because whenever I even take like -3 and I square it, it's going to be +9. It's going to give me a positive value in the denominator. So yes, it is definitely continuous. The next question is f of x differentiable? On this interval. So are there any corners? Are there cusps? Are there vertical tangents? And none of those things exist here, mainly again because we're going to have a rational function that does this. So it is going to be differentiable. And now the last question, or the last condition that has to be met, is the function when evaluated at -3 equal to the function evaluated at 3? Or are these endpoints going to produce the same value? Well, let's substitute them into C. So we'll have 4 over -3 squared plus 1. Is that going to equal 4 over 3 squared plus 1? So we're going to have 4 over 9 plus 1, which is 10. Is that going to be equal to 4 over 10? Yes, it is. 2/5 is equal to 2/5. So yes, it definitely meets all the conditions of Rolle's theorem. So now let's apply it. And Rolle's theorem states that we have to determine what f prime of c is equal to, or find its derivative and set the derivative equal to 0. So let's actually do that. And before I do that, I'm going to rewrite f of x over here as 4 times x squared plus 1 raised to the -1st power, because I think it's easier to apply the power rule, and since we have just being raised to the -1, it's not as much of a hassle. If the denominator was more complex, or if there were variables in the numerator, I would definitely apply the quotient rule here. But since it's just a coefficient in the numerator, we can apply the chain rule when doing the derivative. So let's do that. So f prime of c is going to be, bring the -1 down out in front, so we'll have -4 times x squared plus 1 raised to the -2nd power, and then we have to multiply by the derivative of the inside by the chain rule, which is going to be 2x. And then if we rewrite this, this is what f prime of c is. And I also have to change these x values into c's really quick. To c. All right, and then if we simplify this, we will have -8c over c squared plus 1 to the 2nd power in the denominator. And if we set this equal to 0, first the denominator, are there going to be any critical c values there? The answer is no, because whenever I square, say -3 or -2 or -1, I'm going to have a positive. Then I'm going to add it to 1 and square that value too. So the only critical value occurs where -8c is equal to 0, and that occurs when c is 0, or Roman numeral 3, or answer choice D.